take notes and or pay attention. Like you say, June's going to take a video. Are you started?
Oh, yeah.
Okay. And I'll find a way to put this up on some website or something, make it so you can watch it again over and over and over, okay? All right, so here goes. That is a bottle of water. Not real exciting, okay? This, however, similar but bigger bottle, is
Hydrogen peroxide.
6% H2O2, hydrogen peroxide. I'm sorry I wrote the label as a chemist. Should have written words hydrogen peroxide instead of the formula, but you'll have to deal with it, okay? I've diluted it actually down to 6%, but it's ready to go, okay? So I'm going to pour, I'm about to pour some of this into a test tube. You will want to think about everything I'm doing. I'm kind of doing very sloppily. I'm doing at a level 1 or 2. You're going to want to improve upon what I'm doing. But you will get the basic idea of the process of the lab. But very basic, right? Okay? So think about what I'm doing and how you will improve upon it as I do it. Okay, so I'm going to pour some, that's kind of a hint, H2O2 into this test tube. Okay? 6%. It's going to go over here. I'm using that. I'm going to use some yeast. You will have access to a potato. What the yeast is going to do, and what the potato will do, raw potato, what they do is exactly the same in terms of the chemistry and what you're going to observe. Okay? But I'm going to use yeast to make the same thing happen. You will use a potato. A raw potato. I'll bring in raw potatoes. You'll get to use them. Okay? Anybody know what yeast is?
Yeast?
What is it called in Korean?
Wenjo.
No, not.
All right. Okay. What's it called?
It just says yeast in Korean.
It just says dry yeast in Korean. Yeah. Okay. So it's called yeast. I'm going to use. It doesn't take much. I'm going to use. It comes in little tiny. Go ahead and take a look at that. I'll keep my finger there so you have a size relationship. Get closer. Get closer. You got to be able to see it. Can you see it up there? Those two little tiny beads?
Yep.
That's what I'm using.
Oh, really?
Everything I'm about to do will be because I put those in there, okay? Little tiny, there's my finger for size relationship, okay? Little tiny beads. All right, so what I'm going to do is this. I'm going to take this is a stopper with a glass tube. Let's get up close and personal, okay? Stopper with a glass tube that goes through it that's hooked up to a long, flexible plastic tube, right? Stopper. The stopper happens to be one which will fit snugly in one of the test tubes that's provided, forming an airtight seal, right? This test tube is just an empty one I'm using. But I'm going to do this. I'm going to take my two little beads of dry yeast, maybe if I can get both of them under my finger here, hopefully. Okay, I've got both of them, just a pinch right here. I'm going to drop them into the test tube. I'm going to get down there and take a picture real close. I'm going to put the stopper in the top of the test tube. I'm going to put the other end of the plastic tube into this beaker of water. Film that, not me.
I can see
Get close. Everybody has to see details. Get really close. I want to be able to see right here. Get right down to it. Okay? I don't know if you can see that in the test tube there. Okay, over here. Yeah, it doesn't transmit real good when we're doing Apple TV and everything else. So I don't know if you can see it in real time here, not in the big screen. You can see bubbles forming here. So people can see real also as well as zoom in on that so they can see that it's bubbling. Okay. That could be it. That's the whole lab.
I can see the bubbles.
You can see the bubbles?
Yeah.
Okay. You can see it, but it's fizzing there. Okay. Remember, what's the, I've given you the dependent variable. Anybody remember what it is?
Whoops.
What are you supposed to measure?
The rate of oxygen bubbles forming.
Okay, so the rate of oxygen production. So is oxygen being produced?
Yes.
How do you know? The bubbles? Oxygen, the gas. So something's happening. Oxygen's being made. Bubbles are forming. Nope, keep on that. You don't. They can hear me. That's all they got to do is hear me. Yes.
But how can we know for sure if it's oxygen?
Actually, I could do that, but that's a chemist question. At this point, take my word that it's oxygen. Okay. If you want to, one of these days I can do a quick chemistry test and show you. Chemists have devised over many years. It tells you it's oxygen. Okay. Okay. Somebody talk to me about that word, rate. What's that mean?
You're late.
No, that's late. This is rate. What's rate? If you measure a rate, what's a rate? What's the word rate mean? Wherever you heard the word rate, that's R-A-T-E, where have you heard it used? Anybody ever talk to you about a rate?
Slope.
The
Rate of change.
like a size.
Size? What size is a rate?
Oxygen production.
Yeah? But what's rate?
I cannot tell you specifically.
Okay. And somebody tell me specifically what rate means, Janet? Say again? Speed of something. So you want to use the word speed, huh? That's not bad. Speed is a kind of rate. So let's talk about speed. What is speed? How do you know speed, Daniel?
Speed is like something really fast.
Okay.
Really fast.
How do you know who's fastest?
Wait.
Fastest?
The shaft is.
Well, it depends like which one has like the farthest like distance.
Okay. So let's pretend we're running like, a cross-country race. And everybody runs the same distance. How do you know who ran the fastest?
It could be either the first person or the last person.
Okay.
Two people.
How do you know who ran the fastest?
Time.
Time. Every time we talk about a rate, we use the word rate, time has to be measured. So guess what? You're going to write down what you have to do this lab, and what better be there? What better be there? Well, no, you're not going to measure the rate. What are you going to have to measure so you can find the rate? You're going to have to measure time, aren't you? Every time there's a rate, involved is a measurement of time. Somehow you've got to measure time. Right? Don't use these, they don't work. But you've got a device in your pocket someplace that probably has a stopwatch on it, right? If not, there's websites that do. You have a device on the table in front of you that will take you to a website. Okay, so you're going to have to measure time. What else are you going to measure then? How are you going to measure the rate of oxygen being produced? Yes?
Like that.
What are you going to do? What are you going to do to actually measure the rate of oxygen being produced? You're going to have to measure time. What else?
Oxygen yield.
Daniel.
Maybe the speed as well, like how long it's gonna last.
Well, you're using the word speed again.
How long does it take to like a see all the bubbles.
To give all the bubbles?
Yeah.
Okay.
Into the another tube.
Okay. Somebody else have any ideas about how we're going to measure the rate of the oxygen being produced? We've got the time part down. What else are we going to measure? If I'm measuring speed, I have to do distance and time. What am I going to do here to count, to get the rate? Yeah. No?
I think it's like the amount of oxygen.
How are you going to get the amount? Wait, for what? Mr. June.
Yes. You can find the volume by using a udiometer.
If you want to. Here's what Mr. June's discussing. He's going to take one of these tubes, fill it full of water. Okay, he's going to fill it full of water. That's not a big enough bottle. He's going to get a bigger bottle to put the water in. Pardon me while I do that. Okay. This is hard to do, so you may not want to do this. It's up to you. This is one way of doing it. He's going to put that in there upside down like that. See how that does not get any air inside the tube? And then instead of just letting this bubble, he's going to put the tube down here. This is the hard part. And he has to get the tube to go up into the other tube. My hands are too big. He'll probably have an easier time.
It's okay, sir. I can't have.
There you go. Okay, anyway, that kind of idea, where the tube goes up into the other tube, and as the bubbles go up, they will fill up the tube full of bubbles. Okay? Get the idea?
And then you can measure the volume of the gas.
Okay? That's one way to do it. Anybody else got other ideas? Anybody look at the, I gave you a bunch, if there's a part of your text that has ideas about how to do this. If you read it, I should be hearing what you read. Okay, well, you're going to think about that. Again, I'm not going to just give you the answers, because then you don't have to think, and that's what I want. I want you to have to think. How are you going to measure the rate of oxygen being produced? We've got that you need to measure time. All rates need to measure time. What else are you going to measure? If it was speed, we would do distance and time, right? 10 meters, how fast can you go across 10 meters? We get distance and time. Here, it's the rate. You've got to figure out what else you need to measure other than just time. Okay? Did you take some notes?
Yes.
So what are you using? Who's got some materials?
Like what kind of materials, sir?
Materials are stuff you use and then throw away. What am I giving you? What are you going to use and then never use again? Potato, right? You're going to have, instead of the yeast, you're going to have a piece of a potato or something. I'm going to give you a potato. Okay? What else are you going to use? Say again? Water. What else?
We can see everywhere oxygen.
You're going to make oxygen. I don't know if you're going to use it.
Yeah, but yeah.
What do you use to make the oxygen?
Hydrogen peroxide.
What is that? You need to know what it is, don't you? You need to write that down in your notes, don't you? Okay? I'll write it on the board so you have the correct spelling. Where to write, I can't do the screen and everything else at the time. You're going to follow me around, really? Alright, I